We now begin the next style of problem, blending. Go ahead and open up the handout for blending class examples and read through example 1, and there's also an accompanying Excel spreadsheet. In this problem, we have 4 different chemicals, and we want to decide how do we blend these chemicals together to produce this drug, Nasamyst. Okay, so we have 4 ingredients we're mixing together to make one product. My decision variables are always going to be kind of a recipe. How many pounds of each of these chemicals am I going to mix together to produce this drug? So it looks like that. How many pounds of each chemical will I blend together, mix together to produce Nasamyst? The problem tells us that we must produce at least 1,000 pounds of this drug. Okay, that was just given to me in the problem. If I sum up this column, these 4 cells, that will give me the actual pounds produced. So what I actually produce must be greater than or equal to the minimum required. There's also another quick constraint about chemical 2 that we must use at least 100 pounds of it. So this cell B17 must be greater than or equal to 100 pounds. Again, we got that from the problem, format paint, like that. Okay, we now have these blending requirements, and this is going to be something we find in each blending problem, that there's kind of these ingredients or content constraints. So of the 1,000 pounds that we're producing, 8% must be this active ingredient, B, C, so forth. Okay, we have percentage constraints. Okay, so the active ingredients A, B, and C have constraints. Whenever we compare these, I want to look at the actual amount of these ingredients A, B, and C and compare it to the minimum required. The actual must be greater than or equal to the minimum required. I'm expressing these constraints in pounds rather than in percents, how they're given. To express something in a percent, in particular this actual, if I want to express that in a percent, I need to divide by a total formula. And I can never divide a formula by another formula. It breaks our linearity requirement in order to use solver. So that's why I'm going to express them in just total pounds. So the minimum requirement for ingredient A is 8%. If I'm producing 1,000 or a total, it would be 8% of my total. I'm using just made up numbers to help with our formulas. So I'm saying that I've taken 250 of each chemical, blended it together, and there I made 1,000 of Nasamyst. So 8% of the 1,000 would be 80 pounds. Now I want a formula for the actual amount of ingredient A in my mix. I'm going to take a sum product of my recipe, or what I'm actually mixing together, times the ingredient per pound of each chemical. This is going to be similar for each active ingredient, B and C. I'm just going to lock my total cell B20 so that I can slide it across. And same thing here, I'm going to lock my decision variables. I want to slide across but have those stay in place. Last thing, we want to minimize costs, so we'll create a cost formula. Each chemical has a cost per pound, so I can just take a sum product of how many pounds of each chemical I'm using, comma, times that by their cost per pound. And now let's solve it. Okay, there we have it. All constraints are satisfied, and we have a minimum cost value.